So, coming to Mr. Amol, in response to the increasing demand for data processing and storage, what emerging trends are shaping data center cooling technologies?
Very clearly, there are three trends which I would like to highlight. The first trend is a shift in the applications that data centers are being deployed for. Very clearly, we are seeing more and more high performance computing being deployed. And there are also government initiatives. For example, the Indian government has been running a program called the National Supercomputing Mission. The dream is to have every educational facility with a supercomputing capability available for students to utilize. All these technologies require high density and server clusters. And as a result, the density of the computing starts becoming a challenge. The second trend that we are seeing is the overall target for reduction of the energy efficiency. So PUE as a metric is becoming a very critical component with respect to the strategy of data centers today. There are many companies for whom data center is the business. Usually we call them co-location or hyperscale data centers, where data center is their business. Now for them, a lower PUE directly impacts their bottom line of the business. So it is very critical for them to control. But overall, looking at the speed at which data center infrastructure is building, governments have become concerned. Just to share with you, in our neighborhood in Singapore, there are laws which the government has put in. A customer is not allowed to expand a data center or build a data center until he can commit a certain PUE. That is the kind of controls which are being brought in, because data centers are highly intensive in terms of energy consumption. So these are the trends. Customers want lower PUEs. The customer wants capability to handle high density servers, where the trends towards supercomputing, AI, machine learning, these are the applications which are driving this kind of an application of IT equipment. And that is what is driving towards newer innovation with respect to data center cooling.
Thank you very much for sharing your thoughts. What are your views, Mr. Kapil? What increasing trends do you see shaping the cooling technology?
So, as sir suggests, liquid immersion cooling, I have seen one of the questions also in Q&A. What if any of the pipe leakages happens, or any leakages of coolant or refrigerant, whatsoever is medium is used? So, all that can be traced, tracked, and solution where can be implemented for the same without damaging the equipments, like data center equipments. So second thing is, nowadays we have seen plenty of data centers are precision cooling systems they have been using, underfloor cooling they are using. So where do you see liquid immersion cooling, future of the liquid immersion cooling in comparison to the precision air conditioning?
Okay, so I take both questions one after the other. The first is, there was a question that what happens if there are leaks of the liquid in the liquid immersion cooling, right? So one of the unique things about the single phase liquid immersion cooling is that the coolant is a dielectric fluid. What we mean by that is, it is a bad conductor of electricity. It is like an insulator of electricity. So when we deploy liquid immersion cooling, we actually dip the server directly inside that liquid, and there is no short circuit. So the risk of leakages is not to the IT equipment. The second is, what happens if there is still a leak, right? So typically, whenever we find in hydraulics, there are high pressure systems or high velocity systems. That is where the risk of creating a high pressure which will burst a pipe or fail a joint is high. The overall design of the liquid immersion cooling system is a low pressure system, and it's an open system. It's not a closed pipe system, because the tank is open to the air, right? So because of that, the risks of any leakages are extremely low. The third thing which was asked is it possible to retrofit a liquid immersion cooling in a data center? So I'm very happy to share with you, 80% of our installations are in existing data centers. Now I come back to Kapil's question, what is the future of precision air conditioning, right? So very clearly we are seeing that liquid immersion cooling will not completely take over cooling of data centers. what we are seeing is more hybrid data centers coming in, because liquid immersion cooling solves the challenge of density and extreme clusters, which are largely a server challenge. It is not a networking or storage challenge yet. So, although theoretically liquid immersion cooling can be applied to network and storage equipment also, but we are finding that customers are rightly selecting technologies today. So they would use a liquid immersion cooling in a data center environment to handle these servers. They will continue with the precision air conditioning environment to handle the storage and networking equipments. And overall, because the consumption of power is largely on the servers in large data centers, so they will still benefit from the overall benefit of efficiency. Now, there is also a side benefit of the liquid immersion technology. The side benefit is, because the servers are now coated with the liquid in a liquid immersion system, the servers automatically get protected against corrosion, because the SO2, NO2 levels inside the data center white space is not soluble in the coolants that we use. So they create a preventive layer. But now, does that get rid of the complete solution? Not really. We still need help from innovators like Kapil, because the equipment where I run my pump, my control system, which is inside the data center, that is not immersed. So there we still need a solution. We still need the solution because there are a lot of air-cooled devices inside the data center and even outside, where corrosion continues to remain a challenge, especially in reclaimed areas and some areas which Kapil mentioned. So very clearly, I feel precision air conditioning is there to stay. What we are seeing is a shift in the mix. How much of it will continue to be precision air cooling and how much of it will start getting moved towards liquid immersion cooling. At least in the foreseeable future, I think it is a hybrid system that we'll see around us.
Thank you very much for the update, Mr. Booth. You're talking about the immersion cooling as well as the precision air conditioning. So what sustainable cooling technologies are emerging as alternative to traditional cooling systems in data centers, besides immersion and precision you were just talking about?
Oh, there has been a plethora of innovations that have been coming with respect to cooling in data centers. And I would not be wrong to say that that is a proof that the biggest challenge that data center owners today face is with respect to cooling, because that is what is fueling these different technologies which are getting created. Very clearly, we see three different approaches. One approach is to better make use of air. So we already see that there are technologies like containment systems. Now, be it cold air containment or hot air containment, we all know that containment is better than no containment. We also see that there are different air handling unit architecture which are coming in. So in the last 10 years, we saw from a raised floor cooling approach to a in-row cooling approach where the air handling unit becomes part of the row. We are also seeing fan walls as a technology where the entire wall becomes an air handling unit where it is throwing air into the data center. So there are different innovations. People are attempting to solve different problems, sometimes of density, sometimes of airflow, and sometimes with respect to containment. That is on the air side. There is also equally good innovation happening with respect to different mediums for cooling. I spoke at length about single-phase liquid immersion cooling. But there are technologies where people are using, instead of a dielectric fluid, they are using water or water mixed with ethanol. So there are technologies like direct liquid cooling, or it is also called as a cold plate liquid cooling, which traditionally used to be called water on chip. So right from 1970s, we know that there are servers where the motherboard has a piping of water running on it. So we know that there are risks that what happens if the water leaks, it will definitely cause some failure. But for those particular hardware, some of the OEMs saw that the trade-off was still worth it. They still offer those kind of solutions which are water cooled. We are also seeing two-phase liquids being used, wherein the liquid boils at a low temperature, so they are able to capture more heat, or so is the claim, that because of the latent heat of the evaporation, they can capture heat and again cycle it back. But all these different approaches are really making the data center industry very interesting, because at the end of the day, the customers are getting more options to choose from, because each technology comes with pros and cons, right? So it becomes very interesting for customers to evaluate all of them and see which makes the most sense for them from the current and future perspective.
Thank you for that information. Mr. Kapil, what would you like to say about the alternative cooling systems?
So, yes, as far as technology advancements are concerned, so sorry for the interruption. So, as far as technology advancements are concerned, so there is a need or the demand of the industry, as Mohd has mentioned, hybrid solutions. So, yes, hybrid solution will be replacing the traditional ones. In nowadays, some of the bigger MNCs are opting that, and most probably within 4 or 5 years, you will be seeing plenty of the data centers owner will be using hybrid systems.
Thank you, Mr. Kapil, for your views. Mr. Amod, you were talking about the hybrid, as well as Mr. Kapil were also talking about the hybrid solutions in the coming future. So is the development of hyperscale data center is truly the pressing need in the evolving landscape of data-driven demand?
Oh, definitely. So one of the key drivers of data center growth globally, and I would not be wrong to say, is hyperscalers. We saw that there was a tremendous increase in demand the moment we saw our first lockdowns. Everybody, I'm sure, on the call was very surprised to see how everything started becoming online very fast. And we had never imagined that teachers will be teaching from their homes and students will be learning at their homes in front of laptops, tablets, or even mobile phones, right? That is the extent of internet usage that we saw spurting because of the situation that the globe found itself in. Now, having been exposed to that kind of mode of working, we are finding that now the adoption of remote working is also on the rise as a trend. And that is fueling a lot of requirement of cloud-based systems, right? So everybody wants a way to communicate remotely, collaborate remotely, and as a result, various platforms of different large multinationals, be it Microsoft, be it Amazon, be it Zoom, Salesforce. If you look at any solution today in IT, every solution today is available in some way or the other as a service model delivered through a cloud. And so these kind of infrastructures are definitely growing because of the increased adoption of these technologies. So if we look at the Asia Pacific region, because I largely work in the Asia Pacific region, we are seeing tremendous increase in demand for hyperscale capacities being built in countries like India, Singapore, Malaysia, Indonesia, Thailand, and so on. So in all these countries where it is possible to get a good connectivity to the internet. There is an underlying undersea cables where they terminate. So even in Mumbai and Chennai are one of the two large hubs for data centers because both have a landing station for the internet links. Similarly, Singapore, Indonesia, Malaysia, where there are these kind of environments available, skill set available, energy available, and customers available, right? So that is where very clearly hyperscalers are driving this growth.
Yeah, that's a very valuable insight, Mr. Anadek. Mr. Kapil, you were talking about the reducing corrosion and the standards for testing. So besides this, how do data center adapt their cooling system to reduce energy consumptions and operation cost?
Okay, so as far as corrosion is concerned, that has play with the air only. So via air, the oxidation will happen, and oxidation there are several parameters which I have mentioned in this slide. Like majority of them is the temperature, humidity while designing air conditioning. And for the air perspective, there are plenty more, like one of the major culprit which is overseen by the designers, and in the operational time period that challenge occurs, that is the infiltration. So if the facility is not properly sealed, the infiltration will be there, and that will play a major role in the corrosion itself. So nowadays, plenty of PCB boards are of micro sizes, so the contact points are very, very small in comparison to 10 or 20 years prior to today's era. So the corrosion will erode those points and the failure will happen. This is for the perspective of corrosion. So energy saving, as nowadays everybody is talking about net zero and ESG compliance and energy saving. So yes, there are plenty of technologies available which, as sir mentioned, give 40 to 55% reduction in the energy consumption by implementing or changing the fans and implementing immersion cooling. So I believe there are plenty of researches, or some of the researchers are coming up with the more innovations which can reduce that lower to 55 to 65 and then 70. Then at the end of the day, it will come down to 80%. So you never know as far as the technological advancements are there. So in respect to the corrosion machines, whatsoever machines will be installed in there. So nowadays EC fans are there. So traditionally we were using blowers, motors. So nowadays EC fans are there, which are consuming much less power in comparison to traditional fans. So now every technology is working towards energy saving. So yes, there is a scope of that, and demand is there, need is there. So research is going on there. So that's from my end.
Thank you, Mr. Kapil. Mr. Amod, coming to you, you were mentioning about the artificial intelligence in the data centers. So what role do AI and machine learning play in optimizing data center cooling?
But that's a great question, because when a customer starts putting a data center to deploy AI for certain use cases, it is very natural to ask them, are you not going to use it for your own data center operations? Right? So it's a very natural question to have. Unfortunately, currently what I'm seeing in the industry, most of the AI is being driven towards end-use cases of applications. So we are looking at applications where, for example, legal services or medical services. So there's a lot of research where we are seeing, can something which requires a human to think be handed down to a trained AI engine? And that is to drive more automation, even where there is a decision making involved. So that is the kind of application that we are seeing more to begin with. Although in my last 20 years of experience in the data center environment, I have seen something close to an AI system where there were technologies which were being evaluated, where an real-time CFD view of a data center to be created to see where you can predict a hotspot. Can you prevent a hotspot by modulating the cooling in a proactive manner? So these were some of the interest areas in the industry where I have seen many of the OEMs trying to come up with some information. Unfortunately, I have not seen something which is already launched from a data center application perspective. But I know that the application of AI engines for optimizing HVAC in the comfort cooling environment, I have seen that there are multiple OEMs in the global market which today offer optimization of HVAC energy consumption as a service, where it is being powered by an AI engine over a cloud. But yes, it's definitely an opportunity to see whether that can add further optimization value to the overall sustainability of data centers of their own energy consumption as well.
Thank you for that valuable insights once again. Mr. Kapil, whether AI can solve the problem of corrosion, knowing the corrosion?
Yes. So as sir mentioned, plenty of the HVAC systems are using AI and machine learning to gather the data, and accordingly they can predict and give you the analysis what will happen within a certain period of time as per the current or collected data situation. So for example, if corrosion, we talk about the corrosion prevention equipments. So real-time monitoring, what we are providing is that can capture the data and that can store that data and do the analysis on the same data at what time there will be a need to replace the filters, because ultimately every chemical filtration is of mechanical base, whether is it a chemisorption or adsorption based principle. So that is a mechanical filtration that has to be replaced after a certain period of time. And we can do the life cycle analysis within a certain period of time. Like for example, quarterly, we can do the life cycle analysis. How much life has been left and how much time tenure is it there to replace the filters. The sensors plays pivotal role in that. So sensors can capture the data, and accordingly, yes, data center play a pivotal role in that, because that data sends to the cloud, and from the cloud it will address to the application, from where we can get the details. After 6 months or 8 months or after 1 year, we have to replace the filters. So that AI and machine learning plays a role in the HVAC industry as well as in the any mechanical filtration systems. And moreover, in HVAC system, there are plenty of systems which are of cloud-based. Now there's a paradigm shift towards the cloud-based building management systems, which can save hell a lot of money towards the buildings. So because in HVAC system, more than 50% of the energy consumption is towards the cooling system of the building. So there is a huge saving lies over there if there is a proper data segregation and data capturing is there, so that we can have an analysis how much we can save at which point.
Yeah, thank you for your views and update, Mr. Kapil. Mr. Amol, what are the current challenges and environmental concerns associated with the cooling methods?
So very clearly, I see there are 2 or 3 key themes which come out when we start looking at environmental challenges from air conditioning or cooling systems in general. The first very clearly is whether the medium that we use, whether that itself creates an harm to the environment. So we have seen that there are very strong legislations and regulations which keep getting revised with respect to the ozone depletion potential. So we see that there are many refrigerants, for example, or cooling mediums that were invented, which had very good technical capabilities from a cooling perspective, but when they were found to have ozone depletion potential, they have been phased out. Similarly, the second theme which is coming around cooling is energy consumption. Now, what I want to highlight here, there are typically 2 systems in a data center from an infrastructure perspective. There is an electrical system and there is a cooling system, right? These are the 2 main systems. Now, the electrical system, the only losses that it brings into the picture are the transmission losses. So if there is a UPS, there will be some loss inside the UPS, the cabling will have some loss, that's it, right? So a very, very large portion of the energy actually goes to the IT, where it is supposed to go. But cooling is completely different, because whatever energy is consumed by cooling is just consumed. It doesn't go or flow to the IT equipment. And so looking at the split between power and cooling, today in data centers, almost 50% of the energy of the infrastructure is just in cooling. And so energy and consumption becomes a very primary theme for customers to worry about and to improve upon. Now, very clearly with both of these, what also comes into the picture are the other attributes of the cooling system or the maintenance regime that you run with respect to the overall sustainability or the greening of the overall operations. For example, how do you scrap equipment? When we talk about using different mediums other than air, is there a safe disposal solution which is available, so that when you are disposing of a particular medium, it does not add to the problems of the overall pollution in the environment? And so we are seeing that the awareness with respect to this is on the rise. We are also seeing that the regulations, guidelines, and procedures from the government also being driven across industries, so that this is more under control. And we are also seeing customers valuing it. Today, ESG goals are practically a norm in any organization. And so cooling becomes a very important part, because that is where the largest amount of energy consumption that goes in. Now, the third theme which comes out is with respect to the overall carbon footprint. Right. Now, this will be different globally depending on what the primary source of electricity is. So in India, even today, the primary source is thermal power stations, right? So it is coal-fired electricity that is the primary source in India. Although we have made a huge strides with respect to renewable energy, but the primary source continues to be coal-fired. And that is where every kilowatt saved in a data center on cooling directly helps the country in reducing that many emissions, because that was the power consumption which was happening from a coal-fired thermal power station. And so these three themes I think are very key for India and Asia in particular. The first, which I talked about, ozone depletion potential. Second is energy consumption, and third is safe disposal of harmful products.
Yes, that's a very elaborative explanation. Now, coming to both of you, so to start with Mr. Kapil, how the government regulation and industry standards are encouraging adoption of sustainable cooling solutions? And are there any policies in place to support this transition?
Okay, so for the cooling, I would say sir would be the right person to answer. And yes, for the corrosion and IAQ, indoor air quality, as far as India is concerned, there is no such policy. You will shock to hear that there is no such policy or standards for indoor air quality specifically. For outdoor, yes, there are CPCB standards are there. But for the IAQ, there are no such standard. We are still following global standards like WHO, RESET, and WELL standards for IAQ. As far as corrosion is concerned, yes, there are standards for the condition of the space. Like as I have mentioned in the presentation, G1, G2, G3, and GX grades are there. According to the corrosion happens on the copper and silver plate. So whatsoever sensor we will be placing over the space, they will depict how much resistivity they are giving us. So accordingly, we can analyze that this much of the corrosion impacting parameters are in this space which need to be addressed. So yes, for corrosion, still we are following global standards. In India, for IAQ and for the corrosion, no such standards are there, no such policies are there. We are still looking upon the global standards.
Thank you, Mr. Kapil. What are your suggestions with the above?
So I'm very optimistic about the steps that the government has been taking, especially with respect to data centers. And the reason for that is I have been one of the contributors and participants in many initiatives jointly undertaken by the Bureau of Energy Efficiency and the Indian Green Building Council. So I remember a few years back, there was a revised data center design guide, which was published by the Bureau of Energy Efficiency and Indian Green Building Council, where an emphasis was put on PUE measurement and encouraging energy efficiency with respect to the overall data center infrastructure, which always means cooling, right? Because there is a limit to how much efficiency can be improved in the power distribution system. So cooling becomes the primary target. The second thing where I believe that even if the regulations do not force people to become more efficient, because in data center life cycle, 80% of the spend for data center in terms of operating expense is actually the electricity bill. So there is a very important commercial consideration or incentive for the operator to be more efficient, because it will save more money. So from that perspective, I think there are definitely steps which can be taken more as well. Like we are seeing some countries like Singapore, where they have put a limit that if your PUE is not below a certain value, they will not allow you to build a new data center. But looking at the stage that we are in, where we actually want more and more infrastructure to be developed, I think the commercial consideration that the operating expense is the major expense, business sense itself is pushing people to be more efficient in the way they design and operate data centers. And there are agencies like the Bureau of Energy Efficiency and the Indian Green Building Council, which are constantly working along with the industry to encourage more efficient options being selected from a cooling perspective.
Yeah, that's quite an optimistic point of view. There has to be changes and transition for the coolings. And thank you, Mr. Amod and Mr. Kapil, for your knowledge sharing insights.